Moving on to chapter 11.3, it's going to be a continuation of these kind of dihybrid crosses and like trihybrids, but don't get worried. You won't have to do another dihybrid cross from here on out. We're going to talk about chance, and we're going to talk about like things like multiplying and dividing like monohybrid crosses in this to make it so we don't have to do a dihybrid cross. I always like to start out with this problem here. What's the chance of rolling one on a dice? Obviously, it's 1 in 6. But what's the chance of getting snake eyes? So you have to multiply those together. So it's one divided by 6, 1 divided by 6, and you multiply them to get 1 in 36 chance. So you have a 1 in 36 chance of rolling snake eyes, which are two one-sided dice. So the one on the dice. So we're going to take that kind of thought and we're going to apply it to Mendel's laws. So with Mendel's laws, we're going to see that there is a or mathematically likelihood of again flipping like a coin here or rolling a dice. And if you multiply those together, we can kind of stop doing dihybrid cross. Let me show you what I mean. All right, so it says, what is the probability of two heterozygous genotypes producing a homozygous recessive offspring? So we have two heterozygous genotypes. Again, to get a homozygous recessive offspring, again, we have about a 1/2 chance and a 1/2 chance because if you do the cross, it looks something like this. And you should be able to do this in your head by now. We did this in 9th and 10th grade bio. You should be able to say, okay, these are two heterozygotes. We're going to get this homozygous recessive offspring. However, if we're looking here and we say, hey, what's the in a cross between you can see these genotypes and these genotypes, what is the probability of having this offspring? And you may look at that and be like, oh my gosh, I got to do a trihybrid square. No, you don't. You just have to know how to do monohybrid square. So let's talk about what you're going to do. You're first going to look at the A's here. So what's the chance that we get this combination from these A's? What's going to be 1/2? And if you do this in your head, again, you can do the monohybrid cross. You can actually write it out. And it is still easier doing the monohybrid cross than writing out the trihybrid. So if you're still working on the monohybrids and kind of memorizing them, it's okay. But it's a 1/2 chance you get this combination. Well, for the B's, if we look at our combination of B's, we have big B, little b, big B, big B. What's the chance of getting this? It's also going to be 1/2. Okay. So if you, again, do that monohybrid Punnett square between the B's, and you'll get that 1/2. C's, well, it's 1/2 again. Yeah, this one's a kind of easy one because, again, if we do these C's, big C, little c, big C, big C, well, half the time we're going to get big C, or big C here. So if we multiply those together, we get 1/8. And that's our answer. We don't have to do our trihybrid Punnett square for this. We know that this is going to be 1/8 the time. So 1/8 of the offspring are going to be this combination. Yeah, it's that easy. It's crazy, right? Let's do another one together. Big A, big B, little b, big C, little c. And then you can see the same thing here. What's the probability of getting this? So again, we're looking at each of these. So it's a 1/4 because if we do the monohybrid between the A's, it's a 1/2 if we do the B's, and it's a 1/4 if we do the C's. So 1 in 32 chance. So 1 out of 32 are going to be this combination. Same thing here with the G. I just use different letters here. So what's if we do the combination between big G, little g, and big G, what's the chance we get a big G, big G? If we do the F's, what's the chance of getting little f's? What about the M's? You can see here we have half, half, half again. Again, it's 1/8. So we're also going to do the ors. So you can see here it's what's the chance of getting either of these two. All you have to do at this point is again do the math that we just did, and then you have to just add. So in this case, both of these have a 1 in 16th chance of occurring. So you just add those two numbers and you get 1/8 or 2/16. Here's some more practice problems. I'm not going to go through each one of these, but they're important to know, and it makes getting the dihybrid crosses a lot easier in the trihybrid, and even like anything above trihybrid.